Hello friends, welcome once again to Blessed Excellence Center. Do well to subscribe to our channel. Today we are looking at periodic table of elements. Your presenter is EB Christian. Introduction. Periodic table is a scientific table where all the chemical elements are properly arranged according to the atomic number. A Russian scientist called Mendeleev was the first to construct the table in the year 1869, though he did so according to the atomic masses of elements, which makes some elements not to be properly fit in to the table. Hence, a modification was mandatory to accumulate all the elements, even the ones yet to be discovered. For these elements are now arranged in the periodic table according to their atomic number. And that is the concept of modern periodic law. The modern periodic law is associated with the fact that elements in the periodic table are arranged in order of increasing atomic number and not atomic mass. Let's look at the periods and groups of periodic table. Elements are arranged in the periodic table in a vertical column called group. There are 8 groups, and elements in the same group have the same number of electrons in their outermost shell. The horizontal of the periodic table is called period. There are 7 periods, and elements in the same period have the same number of shell. Now what that means is that in the periodic table we have the groups and we have the periods. So those elements that are arranged vertically are called the groups, and there are altogether 8 groups, while those ones that are arranged horizontally are called period, and there are 7 periods. Okay, good. Now look at the periodic table here, the nature of it. Look at it here. Look at how the elements are arranged. We have the ones arranged vertically. This is vertically, this is vertical, 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 vertical. So all these groups that are arranged in the vertical direction are called the group. So we have this as the group 1, we have this as the group 2. Now in between these ones are not, they don't fall under any group. Then from here we have group, from here this group here, this called this group 3, this group 4, this group 5, this group 6, this group 7, and this what, group 8. Okay, good. So that will mean by group, those ones that are arranged in the vertical direction. Then when we talk about the horizontal, from here to here, horizontal direction, they are called the period. There are 1 period, 2 period, 3, 4, 5, 6, and 7 periods. Okay, good. Now in between group 2 and group 3 are series of elements, or this element you are seeing here. They are called the transition elements. They're called the transition elements. They have unique characteristics. They are mostly used as catalysts. They form complex ion, and they have other properties. So they are called the transition elements. Good. Now down here you can see other group of elements. These ones are called the inner transition elements. They are the inner transition elements, and they include the first line is the lanthanide, while the second line is called the actinide. So this is how the elements are arranged in the periodic table. Now let's see the valence electrons and blocks of elements. Valence electron is the number of electrons in the outermost shell of an element. It is used to determine the block an element belongs. Now there are S blocks elements, we have the P block elements, we have the D block element, and finally the F block elements. So what is S block elements? S block elements are elements with valence electrons on S orbitals. Example, group 1 and group 2 elements. So what that means is that those elements that have their valence electron, their outermost electron in the S orbitals, are called the S block elements, and are the group 1 and group 2. Look at it here. Look at the group 1 element, that is this lithium, sodium, potassium, rubidium, caesium, and francium. These are group 1, this is group 2. So this group 1 and group 2 elements, they are the s block elements because they have their outermost electrons in the s orbital. Okay, good. Now let's look at the p block elements. P block elements are elements with valence electrons in p orbital. Example include elements in group 3 to group 8. All these elements from this group 3 to group 8, all this group here, they are all p block elements. Why? Because they have their outermost electrons in the s orbitals. Okay, good. And let's look at the d block elements. D block elements are elements that have d electrons. Examples are the transition element, as I've shown you guys. Look at the element in between group 2 and group 3 are called transition elements. So all these guys, they have d electrons and they are called the d block elements. Finally, we have the f block element, which are the elements that have f electrons. Example is the lanthanide and the actinide. So you can see the inner transition elements. Look at this to here. They have f electrons, and that is why they are called the f block elements. So that is how far we can go for today. In our next class, we shall be giving attention to the characteristics of those, the property of the elements. Thanks for watching. If you've not yet subscribed, do well to subscribe. Like the video, share it, drop your comment, then click on the notification bell so you can be able to access more of our videos.